So welcome everyone. You know, and I know this. This is the last session in this particular track, and I'm standing in between you and preparing for the super party. So I'll try to give you enough powers through all the knowledge that I can share with from our experience working with our clients in the digital engineering space. Today we basically are going to show you how we can harness the data that we are collecting from the pipeline. As you are running the pipeline, each stage in your pipeline is generating the data. And that data can be harnessed to really make your entire pipeline more efficient. And we will share with you these experience that we have got in field. So just quick introduction. My name is Darren. I work as a director of data solutions with InfoStretch. InfoStretch is a digital engineering solutions company. We work with various clients to solve their DevOps challenges and development challenges. So, today I'm assisted with Mohit. Mohit is not new for the Jenkins community. He is a contributor to the Jenkins community. He was a trainer who had gone through the training during this Jenkins World, DevOps World this year. And he trained the intermediate class. So that's a familiar face for you guys. He works as a tech lead at InfoStretch. So he's going to help me with some demo aspect because just the presentation is one thing. We wanted to show you the things in action and how we are actually implemented these pipelines and how we take advantage of the data. So without further ado, let me quickly give you an idea of what kind of an agenda outline I have. So we'll just touch upon the modern day pipelines and the data they're generating and what the demands are from the pipeline perspective. Then we basically get into the smarter pipelines and the need for the smarter pipelines, why it is really needed, and then actually getting more details into the harnessing the data for efficiency. That is what the key is going to be, followed by the demo, and then I'll open it for more Q&A or any comments or suggestions that you may have later in the presentation. So let's talk about the modern day data pipelines, right? So as you guys know, that digital transformation, right? Everybody is in that buzzword. What really it means is you are building these different type of application, progressive web apps, mobile apps, and you have IoT, and then you're generating a lot of different type of applications, whether it's IoT applications, your partner ecosystem applications, or mobility. You're creating a lot of these applications. Every application which is running through they are adopting their own agile teams, and then some of these applications are going to follow the microservices pattern. All these things are creating a lot of pipelines. Your volume of number of pipelines that you are running is increasing. You must be experiencing that in your work environments. All these things are basically creating a lot of demand on the way you are running these pipelines, how efficiently you are running these pipelines, because ultimately you have finite resources on which all these pipelines are going to run, and all these teams are going to compete for that, and we need to have a smarter way of utilizing our resources. So let's get into what these things really means, right? In a sense, if you look at what has changed, in the release cycles are reducing, right? Release cycles are reducing significantly. The business is demanding more in less time at this moment. So the release cycle is shrinking. The quality demands are very high at this moment. The testing scope is increasing, of course, because as these different variations are coming in. Of course, what it also means is, the demand from your pipelines need to have all these kind of features, like, a higher quality that you're looking for, better management. Your pipelines are supposed to be self-healing pipelines. Analytics is another thing. The insights, foresights that your pipelines give is another demand. Just before us, that was talk about value chain and why it is important to have the visibility in there. It's very important for you to have those kind of features. Compliance and security, that is another important thing that is demanded from your pipelines today. with all these considerations, right, if you look at this, it is important that, we make these pipelines smarter, because if you are not going to make these pipelines smarter, the workload is going to just keep on increasing. So what really this means, right, to make the pipeline smarter. So let's get into a little more in details, right, in a sense, what a smarter pipelines would look like, and what it really means. So to reduce the scope, because we can talk about multiple areas in the pipelines. For this particular discussion, I am going to take the most time-consuming aspect of your pipeline, which is going to be test, right? And you are running different type of tests. You have these pipelines. What you're looking here is really a typical pipeline. Most of you guys have these pipelines in there. Nothing new in there, right? And it takes X amount of minutes. Let's say that it takes X amount of minutes for every time you run these kind of pipelines. Now, every time you make a change, I know that there are practices that are there where some amount of intelligence you use, either tagging or some mechanism by which you intelligently decide, and all these things are done, by the way, manually, where you decide what to run, what kind of a test infrastructure that you need to run a particular pipeline, depending on what module has changed. But still, you will see that the lot of repetition. Every time a module changes, you still are running a lot of things that may not be really necessary to run, right? So if you start really looking at, what are we missing here, right? So if you look at it, think on this way that all this data that we are collecting, right? Everything is generating log. Each and every tool that you have in your stages is generating some kind of log, or it's some kind of a metadata that is available every time it runs. So when you do that, are you actually harnessing that data for getting the recommendations? So that's one thing, right? When the modules change, and one thing that we all know that when we release the product, there's nothing like bug-free product that goes out, right? We do triage, we decide what to punt, what to keep, and what is a safe release, and what is the appetite for us to release. So from that perspective, the changes that are going in, how important that module is, or what are the different module dependencies are, right? If you change one module, what are other things that needs to change? All that information, yeah, today people do it in a very manual way. A lot of time-consuming exercise that people are doing. But can data that is generated through these activities can be used to make this kind of decision? Historical data, you are running these pipelines, and especially the volume that I talked to you about, and with the release cycles that we are dealing with, you are basically running every hour some pipeline. Every time the developer checks in the code, your CI/CD pipeline is supposed to run, and it is generating the data. Every time that run is happening, you're generating data, and that data can be used to do that. That's what we are trying to say here. The more important thing, that is one important thing that we need to also consider, is the resource efficiency, right? So are you using your resources, whether those resources are your build resources, the build machines that you are using, or the test infrastructure for that matter that you are using, right? In a sense, you are spinning up some kind of a dynamic test infrastructure. Are you really using that efficiently? That's the key. If you take into consideration all these competing different pipelines, if you can start really understanding that resource utilization and the cost involved into it, you will see that making these things more efficient by harnessing data is very important. Just to give you an example, one of our clients, and I'll talk about that case study a little later, is actually dealing with mobile devices, and they have this cloud resources that they have through which they are testing their mobile applications. Now, if they're not going to make their pipeline smarter, they actually are paying every time they're testing the thing. They have to use these cloud devices, the virtual devices that they have, the mobile devices for testing, right? So if they optimize it, we are really looking at some improvement in their bottom line as well, right? So let's put it in a perspective, right? Where we started long back with doing the manual release management, but where we are really heading, right? We started doing build automation. We went into DevOps. We all are that in that rate that we are doing DevOps. what we are talking here is actually going towards a smart DevOps, okay, and actually in future looking at more of cognitive nature, where we can start creating the deduced logic, and we can start producing things that can help you make the things smarter. So it's a movement from the doing things to actually thinking machines, right? So you can delegate your work and to these digital workers, and those digital workers can actually effectively do this work for you. So with that, let's get into what, I talked to you about the problem. We explained you, what all things that we really are missing on. What we are really proposing here is leveraging that data to create an impact. As I said, since for this discussion, I'm going to take into consideration just the testing aspect of it. So if I collect the data, right from your requirement management, the code checking that is going in, static analysis tools that you are using, to the test data, the test data management, right, that is going on. All these things, if you start harnessing that data, you can actually start drawing good insights to decide which smokes you are going to run, which regressions that you are going to run, at what point of time you really need some kind of a performance or a security test that needs to happen, and so on and so forth. What we want to do today is, before I get into the nitty-gritties of how we are actually doing these things, we want to show this to you in action, right? So I would like to hand over to Mohit at this moment, where Mohit will actually show you, the pipeline before, after, and then we will also show you the engine behind it and how it is working. And once that the demonstration is done, I'll actually jump into the engine part of it, and I can start talking to you about how we actually achieved it and what else can be done using that kind of an engine. So what you are seeing, the difference here is this the bottom blue box that you are looking at. We are using the QE, or we call it the predictive QE engine. That engine is actually using this data to make these kind of predictions and start generating the configuration, the test configurations on the fly, which can be pulled by your pipeline to make the pipeline more efficient. So over to you, Mohit, if you can.
All right, thank you. All right, so what we have in front of us is, a standard CI/CD pipeline that some of the stages that you're already running in your organizations, right? So standard stuff like checkout, we're going to run some code analysis, we're going to compile the application and run some unit test cases. In this case, I have a Docker example, so I'm going to do Docker linting as well. I'll build the image, run Docker unit test cases as well. We'll package the entire application and push it to our ECR or something like that. We'll do the analysis of the Docker image also. Then we start deploying to dev, and then the typical smoke and regression testing kicks in. So like we said, the focus for this presentation, we are going to keep it only towards testing. However, the concept can be propagated to all the other aspects of CI/CD. So if you look at my smoke and regression testing, you can see that smoke takes an average about 2 minutes, and regression takes an average of almost about 5 minutes, right? Now imagine you doing this, reiterating the same points that Devin just said. You had, let's say, checking only one module in, but then you're running regression test cases for, let's say, 10. That's just an overhead of the whole, you've wasted about 7 minutes of mine instead of 1 minute. Right. So what we did was we took sample applications, we took customer data, and we tried creating, we threw it into an ML and then created a whole solution out of it. And this is a sample set that we're going to show you. Let's say you have different versions that have been happening over the previous time. And then module-wise, the prediction model kicks in and says, okay, we are going to have a risk analysis for these modules. So whatever is red flagged over here probably requires more testing, or that's why you should do more concentration of your testing. Whatever is appearing green, that's more stable, so chances are you need less testing happening on those modules. Now, once a version is released and actual test cases have already run through it, then you have the actual data showing up. right? And then you see that, okay, maybe the prediction model requires some revision, and over time, that prediction changes, and hence even the comparison changes. So the prediction, if you look at from the beginning stages, the modules that matched would be separate. The number of prediction would start getting much more accurate, right? So over time, this accuracy increases, and then by the time you're reaching towards the end, we have a much more mature model that's sitting over there that gives much more accurate data. Similarly, looking at it from a defects perspective, again, you would have the number of defects matching up with the exact high-risk modules and the low-risk modules. And then whichever module you check in, the prediction model would have done its homework already, looking at the different analytical data that's already being published by your CI/CD pipelines, and it has done its generation based on all of that data, right? So if I'm to jump back, so I'm not going to run the before pipeline. So what I'll jump into is the newer pipeline, and I'll just trigger off a build right now in front of you. Fingers crossed, it should go well. Right, so naturally, the first stage is, you're already familiar with it, so I'm just going to, skip through all of that magically, and then we'll jump directly into the recommendation of the ML engine. So if I'm to show you how this would work, it's a very simple, from an, I attended one of the sessions today, and the statement was, if a service doesn't have an API to it, it's a useless service, right? So what you can see over there in the console output, I don't know if it's visible on that screen, is that I'm querying my predictive QA engine, and I'm asking it, can you tell me what should be run for this execution? Tell me what should I run for smoke, tell me what should I run for regression. And it gives me the exact configuration that my testing framework will pick it up. And then once I'm into the actual execution, even from the previous results, you can see that my smoke results have reduced drastically to only 37 seconds, and regression has even reduced further to around 22 seconds. So this significantly cuts down on your smoke and regression cycles, keeps your testing focused to whatever module you're working on, and basically improves the speed at which you release to production. So you can see already smoke has already gone through, and in a couple of seconds regression will go through. So we'll not wait until the whole security and performance testing kicks in, but from there we're good to go.
Thank you. Thanks, Mohit, for the quick demo. So what you saw is actually in action, right? So what has happened is what used to take the time that taken minutes now has reduced really to 2 seconds, right? And it can be further improvised also, right? Because what we are doing here has a very limited set of data, but more the data, the better experience that you're going to experience there. Anyway, so right now I just wanted to jump under the hood, talk to you about more like how we are actually doing it, right? So again, data is a key. Data comes from various sources. In this particular case, we are getting the data from the requirements management tool, the code repository, the code quality tool that we have. In this particular case, Sonar, it was unit test data that is getting generated, of course, coming from your logs, the build logs that are coming out, and also the test management data. All this data is coming to the engine. Some of that is a pull. Some of that is coming through the CSVs and things like that by actually dumping the data logs in particular directory. First thing that we need to happen, right? And this is to you guys who are familiar with the ML practices, the first thing that you need to understand is to get the data and train your model. So before you get into training your model, you need to start sort of creating a unified way of representing that data. Some of your data is going to be more structured, semi-structured, or it's going to be completely unstructured, especially logs, right? So once you take that data, the first thing that you're going to do is you're going to standardize the data. You're going to start massaging and balancing your data. That's a very important state, because what you will see is, let's take these different tools, right? Every different tool has a different interpretation of how they are looking at, say, versions or components, because not necessarily these tools are configured by one single person and nicely named properly. All those things you're going to find. That's a reality of life. So what you need to do is start identifying the gaps and start doing, the data massaging so that the data looks more consistent and more robust. Let's take two examples, right? For example, versioning. So versioning information might be available in some logs. In other logs, you might not be aware of exactly from what is the relevance of that particular log line or anything like that. So, but what you know is by looking at this or putting this data together, you know what dates that you are dealing with. So within the date range, you know what kind of which particular version that is getting affected here, right? So that's one part. The second thing is component. If you don't know the component, how are you going to sort of deduce which component it is that this particular logs are relating to? That is where we are actually using the text classification. We are actually doing the simple text analysis, and we are trying to understand what are the repeating text, right? That is the word that are there, and where this particular component matches. So by doing so, you will start understanding whether this module that you are dealing is a login module, whether this module is is say like a shopping cart or something like that, right? We start understanding what exactly that module that you are dealing with, and you start classifying your data. That's very important part, and we start labeling that data. Once you start doing that, you are now, you have massaged your data very well. Okay, you have that data, and once you have that data, you can use that data more effectively to define the risk, whether it is something low risk or high risk. And I'll get into the details of how we actually go about doing the low risk, high risk kind of an identification. So that's saying that. The another thing is balancing the data, right? Because if you have looked at your past data, before we actually went into this whole agile methodologies, you would have seen that your release cycles were sort of different in size, right? So if you're using some data, and especially with the enterprise clients that we use, some of your release cycles are like shorter, like month or so, and the others are like 3 months. So if you look at the data in the same way, you're going to get a skewing from either way, right? You're going to get a lot of bugs in the same component, but that's not really it. So you need to start balancing out that data. So those are some activities that are very important that you need to get into. Now, this particular case, we do provide some kind of a feedback mechanism or we get a feedback from the user that which releases you want to consider or which releases you don't want to consider, because it's important. We don't want to take all the releases which are actually skewing your results in one way or the other, right? So that's an important. So once all this data massaging and balancing is finished, then you are going to actually get into two important things that we are doing in the particular model that you are seeing here, is the risk prediction, right? So by looking at your data, we are going to start looking at whether that particular module that you're looking at is a high-risk module or a low-risk module. So how do we go about defining a high-risk module or a low-risk module? We look at the bug data at this point, and we look at whether you have what kind of a severity of the bugs that were logged for that particular label, right? You remember last time we first did the thing is labeled everything. Once you label everything, now all your data is sort of labeled, and now we start understanding, okay, for that particular label, we see a lot of bugs reported. Also, you see a lot of check-ins that are happening for that. The unit test might have failed in the thing. Also, about who checked in the code, what is the history of that developer, when to check in the buggy code. All those things are important, right? All those things you start understanding, and once you start taking those things into consideration, you start sort of classifying whether something is a high risk or a low risk. So in the tool, when Mohit was showing you, you saw that green and red items, and how we came to that is really from understanding that data. Now, while doing that, what we do is we throw in the historical. So once we understand what it is, we throw in the historical data back into the for the computation or for the learning. So what happens is now every time you are moving forward, you will start understanding that more and more data is available for the next release, and hence you are just going to improve on the prediction that you're going to make from the risk perspective, right? So that is what we are doing. The second part that Mohit showed you is where we were showing you how many bugs that you can expect. Now, how we came to that point? It's really regression. What we are doing here is we basically are taking into consideration the complexity of the changes that are going on, the stability of that module. Again, looking at all the data that I earlier discussed. Complexity, the stability. We look at also the things like value point. How when story was created and tasks were defined, what kind of story points that were attached to that particular story. Like what is the perspective that the customer has or the developer has, sorry, from that perspective. How many number of blocker bugs were created or high severity bugs were created, minor, major, everything, right? So once you start understanding that data over a period of time and you run your regression models, you'll start telling you a good amount, with a good confidence, how many number of bugs that you may expect in that particular module. And again, I'm going by module. So once you start understanding what is your expectation, what kind of a risk is involved, and what kind of a bugs you can start using that knowledge to make a predictions or start using that data. On the right hand side, what you're saying is that creating the test configuration dynamically, right? You can start saying that, okay, these are the test cases that we would like to run. These are the test cases we may not want to run because we don't want to really waste our resources in running those things. And these things become very, very important when it comes to when you are running running a very large volume, right? With especially more application, different type of devices, what to run, when to run, and still release something with a high confidence. It's a very important aspect, and hence, these things become very important as well. So that is what is really going on here. We provide a REST interface to this particular tool, which I think in the demo you also saw that the pipeline is actually pulling this information, right? At the runtime, it pulls the information, uses the test configuration at that stage to do that. Now, you can actually extend this further. What we showed you today was for the most of the testing stages. Now, this can be done else on other parts also, like you must have seen in our pipeline, we also had this Kubernetes cluster that we spin, right, as our test infrastructure. So when you are doing that, so where the tests actually are running, like if you are using Appium or whatever tool that you are using for testing, how you are going to how many number of actual containers that you need, all those things can be further enhanced. Okay, those are different ways you can look at it. There is a lot of scope for improvisation and taking this forward also. So I just wanted to share a case study. Like I was mentioning with you that earlier that there where we use this thing, right? So we have a European customer which is dealing with this kind of phones. So they are the large service provider. They just look at the size, right? They had like 40 different applications running on 200 new devices. Every time that the new mobile devices, not so much in the Northern America, but in Europe, a lot of vendors are actually pumping these new devices, and it's important that all these applications need to be tested on all these devices, right? Before you actually release those devices or bless those devices. Different device families and 1,000+ maintenance releases in 6 months period. That is the volume that they were dealing with. We went in with this kind of a challenge, and we looked at it like so they wanted to improvise on that. We were also doing their test automations at that point. Our DevOps team was actually working with them to create their value chains. So what we actually came up with is it's better to start improvising that, and that is what I wanted to share. These learnings. So instead of just just implementing the pipeline the way they wanted, we started understanding the data that they were generating. We worked with their data. We improvised it. What you saw, that model was an outcome of that, and we actually could achieve the 30% reduction in the test runtime. Right? That is you can imagine in that kind of a volume is good amount of data, and saving of money because they are using a third-party cloud device provider, and they could actually save money there, and 50% reduction of resource utilization. As I said, a significant amount of savings from the monetary perspective as well, right? So there are definitely good outcomes. If you start thinking from your perspective, like start looking at your pipelines, the data that you are generating, and start asking these questions that I earlier asked. Are you using your pipeline more effectively, right? In a sense, is that data that you're generating, can that be used to actually making your pipelines more smarter? There are ways. Just wanted to share those different ways, that you can actually harness your data and make your pipeline smarter. So that's what we wanted to share today. I'm going to now get into questions, comments, if you guys have any specifics that you would like to know about our experience, or if you want to, not share right now, and if you want to talk later, we are at, we have a kiosk here at 909, I guess, right? Yeah. So, if you want to just stop by, you're welcome, and, we can talk about your specific cases also. But yeah, the forum is open for if you guys have any questions or comments, or if you want to share your experience about making the pipeline smarter and leaner and more efficient, it'll be great. Thanks, guys. Any questions? We have a mic here. I can pass on the mic if you guys have any questions.
So in the previous slide, when you say 30% reduction in the test runtime, is that because they're running less tests?
Yeah, so we basically are looking at the actual test, right? Which tests you are running, and we basically are running only the smokes and regression that are needed, rather than running everything that they were running earlier. So that is where the runtime came into picture. So less number of things you are running for that much amount of your device on cloud is active, and you are actually saving that time as well as the uptime for that particular resource as well. Right. So risk prediction. So I talked to you about the risk definition, right? So we were predicting the risk of a particular module, whether that module is a risky module or it is a non-risky module. So that what you're seeing here is really the confidence level, like at what confidence, because see, it's ultimately a module it's just a model that is doing a prediction, right? So what you're looking at here are the confidence level at which the predictions were made. Yes.
How often you update the model?
The one model that you saw about the risk is really adaptive, right? So it is actually, as I said, we are throwing the historical data back into the mix, so it is really doing it. The regression model is updated as more and more features are available. Okay, so if in particular scenario, the customer scenario, if more features are available, we can actually update it literally on a monthly or quarterly basis. Yeah.
I may have missed it, but how does the feedback loop work if there's tests that you aren't running because they're deemed low risk, and then they result in a failure in production?
Sorry, I didn't get it. So yeah. So what about the feedback? Can you repeat your question?
Yeah, so like the idea is that you don't run tests that always happen. Correct. So if you're not running those tests and something fails, how does the feedback loop get back into the model?
Because now your logs are going to get recorded, right? So basically you are reading those logs. So test log test management logs is one of the input for me, right? To understand whether I made a right prediction, did I not run something which was supposed to run, and this is going to get better over a period of time, because more the data, merrier the things are going to be. So yeah, so that is how. So every run is producing the data, and that data need to be harnessed to make your predictions better. Sure. Any questions? Okay, great. Thank you. I hope this helped you. And if you need any further discussion, we will be here for a few more minutes. Thank you very much, everyone.